Hello and welcome to IoTGyan. This is Tapan, and today in this session we'll learn about NodeMCU. So these are the points. We'll go through the introduction, specification, firmware, the pin description and modes of operation and many more things. So let's start. So what is it? A NodeMCU development board. It is an open source IoT development kit where everybody can get it and everybody can program it. In its hardware, it is based on ESP12E module, which is this one shown in the photograph. It includes a firmware which runs on Wi-Fi SoC. This is the Wi-Fi SoC and it is named as ESP8266. And Expressive System, it is the manufacturer company who has built this. Whenever you listen term Node MCU, by default it refers to the firmware rather than the development kits. So it is all about the firmware what you are using. Here we are using Lua scripting language as a firmware. There are many platforms available, but still we are using Node MCU due to some of the reason because it is low cost hardware. It is very simple and it is easily available. Let's move ahead. What are the technical specs? First, it is a high integration wireless SoC. Means lots of components in a small chip. That is called high integration. It is developed by AI Thinker team. I'm talking about Wi-Fi module. So AI Thinker built it. Second, it has integrated low power 32-bit microcontroller unit called Tensilica L106. Generally, it supports clock speed of 80 megahertz, but for higher end application, you can overclock it up to 160 megahertz. It is having an inbuilt 10 bits ADC, and which is available on A0 pin. It is having inbuilt TCP/IP protocol stack. It supports wireless standards IEEE 802.11. Uh, it runs at its Wi-Fi runs at a frequency of 2.4 gigahertz, and it has 20 dBm output power. Network wise, it supports three kind of modes. First one is the station mode, then access point mode, and third one is the hybrid mode. It is having various interfaces like UART, I2C, where you can connect a number of ICs, I2S for audio, PWM for pulse width modulation, GPIO you know very well, and SPI interface. They are also available on this chip. It is having a deep sleep power mode. If you want to run a longer battery, so you have to deploy this mode where its power consumption it is 1 milliwatt, and at that time it will be drawing a current less than 10 microampere. It supports a real-time operating system. It supports RTOS. So let's go through its firmware. It comes in three flavors. First one is the Lua. So what is it? It is a powerful, efficient and lightweight embeddable scripting language. Moreover, it supports procedural as well as object oriented programming. Why it is used? It is mainly for video game development. So this is the URL for more details. Second firmware is MicroPython. So it is a small version of Python 3. So it is lean and efficient implementation of Python 3, and it includes only a few parts or a small subset of Python standard library, and basically it is optimized to run on microcontroller and constrained environments where we are constrained with limited sources of memory in terms of speed, in terms of other resources. Third one is the Sprino. So what is it? It is an open source and open hardware JavaScript interpreter which can run on microcontroller itself. So by using Sprino also we can work on ESP8266. Before going into the pin description, let's take a look at what are the components physically you can see. First, this is the pin. When you want to externally reset it, just press this reset button. Whenever you want to burn a firmware, we have seen Lua or MicroPython, you are supposed to press this button, flash. The biggest component is ESP8266 Wi-Fi SoC, which can be used as an access point to send your data to cloud. This is the antenna which is used to send the RF signals. And last but not the least, this is the CP2102 IC which is used to convert USB into the serial. So these many components they are physically you can see. Now let's come to the pin description. First, HSPI interface, it is available on this chip. Whenever you want to interface display screen or another MCU or some SPI flash, you are supposed to use pin number 5678. So let me show you. This is the 5678 for HSPI. Next is the PWM. Whenever you want to control the brightness or the intensity or anything with any quantity which is analog in nature. So you can achieve the PWM output on the pin number 2568. So whatever you can see as a sine wave signal, these are the PWM outputs 2, 5, 6, 8. Next is the A0 pin. So it is the only analog pin available on this NodeMCU where you can connect some sensor and which is giving you the analog quantity. And it is having 10 bits analog to digital converter inbuilt in this. Next is the I2C interface. Whenever you want to connect n number of ICs, I2C interface is used where you can connect displays like OLED or some sensor. So they are available on pin number 1 and 2. So this is pin number 1 and 2 for I2C. There are two UARTs available. First one is the UART 0 and second one is the UART 1. But this UART1, it is having only transmit only function. You cannot receive anything. So let's take a look at UART1. So it is available on pin number D4. Where is D4? This is the D4. Here UITXD is written. There is no pin for receiving it. Okay. So next thing is UART0. UART0, it is available on TX and RX pin. See here TX and RX pin, they are available, and it is a UART0 where you can have UART interfaces connected with the board. Next thing is the audio data. So for dealing with the audio data, I2C uh, interface is there. Here you can give input to the microcontroller and you can take audio output also from it. So for giving audio input to this NodeMCU, use pin number 5, 6 and 7. So this 5, 6 and 7 for giving audio input to this chip, and pin number 8 RX and D4. 8, this is the pin number 8 RX, and next is D4. This is for taking output from it. Functionality wise, ESP, it is very rich. You can generate IR frequency on pin number 1 and 5, and you can control an infrared devices connected to it. So this is pin number 1 and 5 for IR. Next, from D1 to D8, these are the GPIO pins with PWM functionality. Whenever you want to control the intensity of something or you want to get an analog output, you can use pin number 1 to 8. Next is the D0 pin. So where is the D0 pin? Here. So D0 pin, it is internally connected to one of the LED, this blue LED. Till the time ESP is under operation, it will keep on glowing. So this is the digital IO pin only. You cannot get any other functions from it. Next is the next which is acting only for digital IO, that is SD2 and SD3. So this is SD2 and this is SD3. You cannot take any other function from it except GPIO. So collectively we can see total 11 pins are available as a GPIO. From D0 to D8 there are 9 pins, and SD2 to SD3, 9 plus 2 11 GPIO pins they are available on NodeMCU. Next is the EN pin, which is the chip enable pin. So till the time ESP it is in operation, it is enabled, it is high. Whenever you want to disable it, you can ground this pin to disable the board. Next is the reset pin. We already discussed. For external reset, you can press this button. You can give input on Vin, which will be ranging from 4.5 volt to 9 volt. So you can connect any power supply in this range to the ESP8266. Next is the 3.3 volt in the ground. Whenever you want to connect a sensor, so these pins, they are available on this board at many places, like here 3v3 and ground is there. Here also you can see 3v3 and ground. So this is for connecting the sensors. So this is all about the GPIO pins. Now let's take a look into the network mode of operation. It will work into the station mode or access point mode or the hybrid mode. You can see into this figure there are a number of devices. Let's say this laptop, this is the mobile phone, and another ESP. So there is a router which will be acting as an access point for all these three devices. So you can connect all these three devices to this access point from where it can be connected to the internet. This ESP and this ESP, both of them will be acting as a station point. This is the STA mode. Next is the access point mode. Let's say this is the laptop, this is the mobile, and this is another NodeMCU. And this, in this ESP8266, it will be acting as an access point whereby using a dynamic host configuration protocol, its duty is to assign the IP addresses to all these gadgets so that a local network can be established by using this access point. So this is the second mode of operation, and this is the hybrid mode where it will be acting in station plus access point mode. Let's say this is the laptop and this is the node MCU. So this station will be sending its data to this access point. So this ESP will be getting this data because right now it is acting in access point mode. After some time it will be again switched into the station mode, and this is the actual access point. So it will be sending its data to this access point. There is no question for connectivity, definitely it will be there. So in a moment it will be switching from station mode into the access point mode, and this is the hybrid mode of operation. And from this access point it can be connected to the gateway and finally to the internet. So let's move further. I have given some additional functionalities in ESP. If you go through the slides, then you will come to know. So for further detail, you can consult these slides. And this is all about the NodeMCU. Thank you.